Imagine a machine that doesn't just follow instructions but thinks and learns from its environment. What if a robot could adapt, improve its decisions, and even surprise you? In today's video, we're diving into how robots actually think and learn. Let's unravel the mind of a robot. The concept of a robot's mind. When we talk about the mind of a robot, we aren't referring to neurons and emotions like in humans, but rather the sophisticated systems and technologies that enable them to process information. At the core, robots are equipped with sensors that gather data, processors that make sense of it, and software that powers their actions. This data could range from temperature readings, images, to movements around them. These sensors give robots the ability to perceive their surroundings. Think of it like their version of sight, hearing, and touch. What powers a robot's thinking? At the heart of how robots think lies artificial intelligence, or AI. Through algorithms and learning techniques, robots are able to make decisions, interact with humans, and adapt to new situations. AI versus traditional programming. Unlike traditional programming, where every action is explicitly defined, robots with AI can modify their actions based on previous experiences. It's like teaching a robot to think for itself instead of simply following orders. AI components. Robots use algorithms like decision trees, neural networks, and deep learning to process complex tasks and even improve their behavior over time. How do robots learn? Machine learning. Robots use a subset of AI called machine learning to learn from data. Rather than being manually programmed for every action, robots use datasets and examples to train themselves. For instance, a robot learning to sort objects might first be shown thousands of labeled images to understand differences between shapes, colors, or sizes. Over time, it begins to identify new objects on its own. Types of learning. Supervised learning. In supervised learning, robots are given a set of labeled data and taught by examples. Think of it like a teacher showing you a picture of a cat every time, so you learn to recognize it in the future. Reinforcement learning. This type of learning involves trial and error. Robots receive rewards or penalties based on their actions. For example, a robot learning to navigate a maze gets positive feedback when it moves closer to the exit and negative feedback when it hits a wall. Unsupervised learning. Here, robots try to find patterns in data without being explicitly told what to look for. It's like discovering hidden relationships in a sea of data. Real-world examples of robot learning. Some of the most impressive examples of robot learning come from industries like manufacturing, healthcare, and even entertainment. Autonomous vehicles. Self-driving cars use machine learning to understand the road, recognize pedestrians, and avoid accidents, all by learning from massive amounts of real-time data. Factory robots. In manufacturing, robots continuously learn from their environments to optimize tasks like assembly, packaging, and sorting. Healthcare robotics. Robots in healthcare, like surgical assistants, learn from previous surgeries and adjust their techniques to improve precision and safety. The future of robot learning. As robotics and AI continue to evolve, robots will not only learn faster but also become more intuitive. We're moving towards a future where robots can autonomously solve new problems and make decisions in real time, adapting to changes in their environments. Imagine a robot learning a new skill just by watching a human demonstrate it. Or even robots that can teach themselves how to perform a task in ways we never expected. The possibilities are endless. Can robots learn without humans? While most robots learn with human intervention, there's a fascinating field where robots teach themselves. Self-teaching robots. Imagine a robot that can explore its environment, make mistakes, and learn from them, entirely independently. This is a field of robotics known as autonomous learning, where robots build their own knowledge base without a human teacher. Example, in 2017, a robot at MIT learned to pick up objects by watching humans, but without any direct instruction. Over time, it developed its own strategy for grasping various shapes. The ethics of robot learning. As robots get smarter, there are ethical questions we need to think about. Should robots have rights? Can a robot make ethical decisions? Machine bias. Just like humans, robots can develop biases based on the data they learn from. For example, an AI trained with biased data might learn to favor one group over another, which could have serious consequences. Robot autonomy. If robots are capable of making decisions, can we trust them to act ethically? Could a robot make life or death decisions, such as in autonomous vehicles or medical surgeries. Thought-provoking question: when robots are learning on their own, how do we ensure their morals and decisions align with human values? Section 8. Learning like us. Can robots develop emotions? While robots don't have feelings the way we do, some cutting-edge research is exploring emotional learning in robots. Emotional AI. Researchers are developing robots that can recognize human emotions and respond accordingly, an area of AI called affective computing. This allows robots to respond to a person's mood, creating a more human-like interaction. Example: robots like Pepper are designed to detect emotional cues like facial expressions or voice tone, and can adapt their behavior to make people feel more comfortable or understood. Challenge: could a robot ever really feel emotions, or are they simply simulating it? The brain behind the robot. Deep learning versus human learning. To understand robot learning, we need to compare it to how humans learn. Let's dive into the differences between a robot's deep learning algorithms and our brain's neural processes. Deep learning versus human brain. Humans learn through complex networks of neurons firing in response to stimuli, while robots simulate similar networks through artificial neural networks. However, robots can process massive amounts of data much faster than our brains. Key difference. While our brains are incredibly flexible and capable of handling a wide range of tasks, robots are specialized in specific areas, learning much faster in a focused domain. For example, a robot might learn to analyze medical scans faster than any human, but it couldn't teach itself to play the piano. Section 10. How robots learn from failure. Embracing mistake. The power of failure. In the world of robotics, failure isn't a setback, it's a critical part of the learning process. Robots, especially those trained with reinforcement learning, improve by making mistakes and refining their actions. Example: for instance, a robot learning to walk might stumble and fall, but each time, it tweaks its steps, gradually improving its balance. This trial and error process is very similar to how a child learns to walk. Real-world parallel. Just like humans, robots use mistakes as opportunities to grow. This makes them incredibly resilient learners. Is there a limit to robot learning? As incredible as robot learning is there a point where they simply can't go beyond their programming? Can robots ever truly think outside the box? Limits of AI. While robots are getting better at learning, there are still limits to their understanding. They may excel at narrow tasks, like playing chess or sorting objects, but struggle with tasks that require true creativity or emotional insight. Theoretical limits. Some argue that there will always be a point where robots hit a wall in their learning because their neural networks can only work within the confines of their programming. So, the question becomes, can robots ever achieve general intelligence like humans? The robot brain. How do they process information? Brain-like processing. A robot's brain is made of circuits and processors, but how does it actually process all the information it gets? Let's take a deep dive into the architecture behind robot thinking. The neural networks inside robots. Just like our brains, robots use something called neural networks to process information. These are layers of algorithms that help the robot analyze data and make decisions. The more layers, the more complex the decisions a robot can make. Example: imagine a robot that needs to recognize an object. It uses its sensors to gather visual data, sends it through several layers of neural networks, and eventually makes a decision. This is a ball. In a fraction of a second. Can robots teach other robots? In the future, robots could share what they've learned with each other, creating an entire ecosystem of collaborative learning. Collaborative robotics, cobot. Some robots are designed to work together, learning from each other. When one robot learns a new task, it can communicate that knowledge to another robot, which accelerates the overall learning process. Example: in manufacturing, robots often work alongside humans. If one robot learns a more efficient way to weld, it can share this with its peers, leading to smarter, faster production lines. The potential. This shared knowledge could lead to an exponential increase in how quickly robots can master new skills, faster than any one human could. Section 14. How will robots change our education system? One of the most exciting potentials of robot learning is its ability to revolutionize education. AI tutors. Imagine a classroom where robots act as personal tutors, adapting to each student's pace and learning style. Robots could quickly identify areas where students are struggling and offer personalized support. Classroom assistants. Robots could also support teachers by automating repetitive tasks, allowing them to focus more on creative teaching strategies. They could assist with grading, track student progress, and even help teach coding or STEM subjects. As always, we're just scratching the surface, and the journey of understanding robot minds is only just beginning. What are your thoughts? Do you think robots will surpass human intelligence? Or do we still have a long way to go before they truly think like us? Leave your thoughts in the comments below. I'd love to hear what you think. If you enjoyed this deep dive into the mind of a robot, don't forget to like, share, and subscribe for more exciting content. Thanks for watching, and I'll see you in the next video.